I'd like to walk you through the corrections for your Chapter 2 quiz, and I'm actually going to start at the end. So what we did was we did group activities on these two things. This, you can go back and look at 2E polygons for this. This is what we did when we looked at the different characteristics in our group work of different polygons. And we looked at how do we find the angle sum for each of these polygons. So in our group work, we know already that a triangle, the angles of a triangle, will add up to 180. So that's the angle sum for this shape. So using what we know about that, we took each of these shapes, a 4-sided, 5-sided, 6-sided shape, and we drew lines, not lines that crossed each other, because then we're creating more angles, and it gives us a false reading. Just creating two triangles, and those will each add up to 180. So we've got 4 sides, and you notice that each time we look at how many triangles fit in, it's actually 2 less than the number of sides, which is handy. So a quadrilateral is actually 2 triangles. 2 times 180 gives us 360. This is the angle sum for a 4-sided polygon. A 5-sided polygon will have 3 triangles in it, 2 less than the number of sides. So 3 times 180 is 540, and that's the angle sum of a 5-sided shape. So I'm working with a 6-sided 6-sided polygon, which is a hexagon. So the angle sum of that, I mean, we could go through and draw these triangles, but we know that the sum is going to be the number of sides, 6, minus 2. This is the formula that's in 2E, times 180, which is the amount, the angle sum of a triangle. So that's how we arrived at 4 triangles worth times 180. The angle sum of all of these is going to be 720, so we really needed that. So if we're looking for the value of A, which is this angle here, we take 720 minus each of these angles plus the right angle that we know, and that gives us that A equals 140. Then we can go outside and we can do the hefty work of figuring out what each of these angles is based on supplementary angles and that, or we can just recognize that any polygon, a convex polygon, that has these external angles, it will, like a circle, all add up to 360 degrees. But to prove it, you could work out each one of those. So a regular polygon, this is not. A regular polygon has all the sides the same length. So if this were a more, what would a regular hexagon look like? Pretty much like something like that. That's not even close. But if they were all equal, then we know that we divide these angles, they'll be equal as well, and 720 divided evenly by 6 gives us 120. So that's 2E, and you can go back and review 2E on Canvas for a little bit more. This one was a little bit tougher. This one, sorry, the lower one, number 7, had to do with, I think you say Euler, and because he was Swiss German, Mr. Rafferty and I say Euler. Euler's law, like Sigmund Freud and Euler. We did all this. So basically we looked at the number of faces, which are the planes, the flat surfaces, the number of vertices, which are the points at which those meet, those angles happen, and the edges. The edges are the long lines along here. So you played with these shapes and you came out with these numbers, and really cool, you will have seen, and I'll remind you where all these answers are, that they all add up to 2. So what you were trying to prove in this one is that this is the rule here. The edges will equal the faces plus the vertices minus 2 every time. And so how we did it was name this polyhedron, many-sided thing. You could call it a pentahedron because it's got 5 sides, or a square pyramid because it's a square. A squareamid? It's like a new sea creature. It's a pyramid that's based off a square. How many faces does this polyhedron have? 5. Triangle, 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 square. How many vertices does it have? These are the points here. And again, we did this in our group work. Okay, now this is the one that probably is most confusing. Show the polyhedron satisfies Euler's rule for solids. So if we know that rule, this is 2F. You can go back and I walk through you in 2F for this. This one has 5 faces. It has 5 vertices. 10 minus 2 is 8. And if we go and check, we will see that there are 1, 2, 3, 4 edges along the square, 5, 6, 7, 8 along each of the pyramids. Now, the rest of this is probably reasonably self-explanatory, but go through and do the rest of your corrections. And once you have done that, if there's anything you still don't get, I want you to put a big ring around it so that we can come back and we can talk about it. And again, you're going to go, after this, go back and do a little bit of further practice with 2E polygons and 2F solids. And I'll have just a limited number of exercises that you can do there. They'll be highlighted. Just to clarify where to find what you need on Canvas, you're in Chapter 2. The solutions to our group work, that's there. So each of these different things is laid out there for your solutions. And then the quiz solutions itself, which I've been referring to in the video, are obviously there because you found your way to it. Go back and review polygons and solids and do the selected work there.